Hello, everyone. Welcome to this monthly webinar on the Southwest drought conditions and resources. My name is Joel Lisenby. I'm the Regional Drought Information Coordinator for the Intermountain West and Southern Plains regions at the National Drought Information System, which is NIDIS. NIDIS is a much easier acronym than trying to spread it out. If you're not familiar with NIDIS, head on over to drought.gov. You can learn about what we do there and who we are. You can also sign up for email alerts for whenever the drought status changes at your zip code. You'll get a little email that says, hey, the drought status changed at your zip code. For those of you that are unfamiliar with this webinar series, thank you for joining us. If it's your first time, we usually try to keep these briefings to about half an hour. They're very casual conversations. We'll highlight the current state of drought across the Southwest, and we'll also highlight some of the great work that's happening across the region to help build resilience to drought conditions here. I also just realized that I was supposed to be sharing my screen and I haven't. So I'm going to quickly share my screen with you, and so you can see some information as I'm talking about it. Oh, of course, it's not going to let me do it while I'm talking to you. Whatever. We'll just keep going. Here's just a little bit about these briefings. They're usually about 30 minutes. We started doing these back in 2020, when the Southwest drought really started ramping up. They've been put together. It's been very much a collaborative effort between me at NIDIS, Emily Elias at the Southwest Climate Hub at the USDA, and also Curtis Riganti from the National Drought Mitigation Center at the University of Nebraska in Lincoln. They've been the primary co-organizers here, but we've pulled in a lot of experts around the region over the last 2 years to make these webinars great. This has been a collaboration that's been part of the Southwest Drought Learning Network. This Drought Learning Network aims to support peer-to-peer learning by linking climate service providers with resource managers and resource managers with each other to share ideas that helps people be resilient to drought and build community resilience to future droughts. I want to go through just a few logistics about this webinar. Everyone is muted, and this webinar is being recorded. The recording for the webinar will be posted at drought.gov/webinars probably later this week. It may get pushed to early next week. When it gets posted, I'll send out an email to those of you that registered to let you know that the recording's online. If you have questions, you can ask them at any time throughout the webinar by typing them into the questions box. If you're not familiar with the GoToWebinar platform, the questions box and the chat box are two different things. One's called questions, one's called chat. So if you have a question, type it in the questions box. And after both presentations today, we'll have a few minutes for questions. Questions will be, and we'll just read through the questions as they come in and ask our presenters. Now, I'm quite honored to be able to introduce and welcome our two presenters today. You can see them, their cameras are on the screen, so hello to both of you. First, our first talk is going to be from Dave Dubois. Dr. Dave Dubois is the state climatologist for New Mexico. He's also the director of the New Mexico Climate Center and associate college professor at New Mexico State University. He provides climate and climate change information and education to policymakers, the agricultural community, industry educators, students, and the public. In addition, he also gives numerous talks and holds workshops every year on topics covering climate, drought, air quality, and climate change. So very, very big welcome to you, Dave. Thank you for being here. Immediately following Dave's talk, we're going to be hearing from Tsegaye Tedessa. I probably said your name wrong, even though you just told me how to say it right. Tsegaye is a research professor of applied climatology and remote sensing at the University of Nebraska-Lincoln. He's also a geospatial coordinator at the National Drought Mitigation Center. His research interest is developing drought monitoring and prediction tools. Okay, so that's the introduction. Dave, I'm going to give you the presenting permissions. Oh, actually, you already have presenting permissions. That's probably why I couldn't share mine earlier.
All right.
So we're seeing your screen now. And,
okay.
When you go into presenter mode, you can just get started.
All right. All right. Can you see the slides?
Yes, we can.
All right. Well, thank you for that introduction. And so I just start off with a nice picture of the fall colors that we're seeing across our region. And depending on where you are, you may be seeing a lot of white. I know folks are seeing some snow in the higher elevations. This is what it looks like down where I am, down in southern New Mexico. And let's get started. Let's talk about kind of where we are, where we've been, and where we're seeing where we're heading. So get started here. So I always just start off with the U.S. Drought Monitor. So from last week, and remember these come out on Thursday mornings. And so this is a depiction of drought currently, and as you can see, there's a big mix, and we'll kind of pick a little bit of this apart in the next few minutes. So you can see there's still areas of D4 in California, and as you go further east, you can see the fingerprints of our nice summer precipitation through the monsoon in the areas in Colorado and New Mexico. We're seeing D0 and a few D nada areas where there's no drought. And according to the U.S. Drought Monitor, that is, there's still a few areas of lingering drought that we've seen over the past few years. Few of the areas of D3 in eastern New Mexico. That's an area where we'll be talking a little bit about missing out on a lot of the warm season precipitation, as well as across the Great Basin in Nevada and big areas of Utah. We're still seeing D3 and a spot of D4 in central Utah. So it's kind of interesting to watch the monsoon, and kind of looking at starting from the last spring and then kind of proceeding into the summer and then into the fall. And we can use the drought monitor to kind of help us guide ourselves on to see how we've progressed. And so this is a drought monitor change over the last 8 weeks from September 13th to last week. And as you can see, there's been some really good improvements across much of the area here. And let me move this little icon out of the way so I can see my screen. So we had a 5-class improvement in New Mexico. As you can see, that area where this is from September 13, but if you go a little further back, there's been a 5-class improvement in that little area in southwestern New Mexico. And remember back then in the spring, we came from big areas of D4 through into Texas, which is not shown here, but in New Mexico, where we had up to a little more than half of the state in D4. So let's look at using our PRISM data set, looking at precipitation from June to October, kind of ranking them. As you can see, big areas of New Mexico, Arizona, southern Colorado, and parts of Utah and southern Nevada were above average, above normal for precip. And a few areas we had record. So just some stats on the bottom of the slide there. Statewide, Arizona, June through September was the 6th wettest for the whole state. And then over that same time frame from June through September in New Mexico was the 13th wettest. However, if you look at that spot over here in the west side of New Mexico, and that's we call Climate Division 4, they had their wettest June through September on record, and you can see that. And driving through there, and you can see the vegetation ecosystems have responded. However, for temperature over that June through October, even though after the monsoon, it's been a bit cooler. The overall time period, it's been above average for pretty much the whole area. A few areas of right around normal to just above normal in New Mexico, but even all across the Great Basin, Utah, western side of Colorado, and the Four Corners, it's been above average. So just kind of peeking at the last month, this current month that we're in, the upper left is the precipitation anomaly percent of average. You can see it sort of dried out in New Mexico and West Texas, and as well as in southern Arizona. But however, there's been some storm tracks bringing precip, some good amount of precip, and even some snow in the higher elevations throughout the Southwest. And then on the bottom right is the temperature anomaly. As you can see, the majority of you can see that line kind of going all the way up from eastern New Mexico all the way up to Minnesota, above average. and right around average for parts of New Mexico, and then slightly cooler in the west parts of the Southwest. So we've seen like I think in the last briefing from last month, we've seen the summary of the monsoon. As you can see, that lingering impacts are still in the soil. This is the GRACE satellite-based root zone soil moisture. That's down in the top meter of soil, seeing that signature of wetness. That's as good. And then also if you look at the model-based, the land information system through NASA SPOR, which I've been looking at quite a bit, just kind of comparing the chunk of time the last 6 months has been pretty wet, and kind of that still lingering, which is good, compared to other years. We've seen really dry soil columns, but this is, I guess, setting us up for a good position for the winter. So where's that water going that had fallen, and then kind of looking at the longer term drought. This is on the left side, we see the lower Colorado reservoirs, and we probably seen the news talking about the drought impacts on the Colorado water in Lake Mead. So it's at 28% down just at the 1,044 foot level, and then on the right, our upper Colorado basins, Lake Powell's at 25%, Navajo, which is in New Mexico, at 53%. So you can see the impacts of long-term drought. And then going over further east into the Rio Grande, you can see the impacts of our long-term multi-decade drought. Elephant View has just got into around 8% of capacity, as well as even some of the Pecos basin reservoirs are low. And then going over on the right side, the Rio Chama, the upper parts, Abiquiu at 65%, Heron at 12%. So this is a graphic that I got from the New Mexico Office of the State Engineer. Basically, it's a total reservoir volume storage in New Mexico. There's a total of 12 reservoirs, and basically looking back, going all the way back to 1990, and kind of going to the top there. If you can't see it, goes all the way up to 5.5 million acre feet, and then each bar is a year. And so that far right bar is the 2022. As you can see, we're right down there, real low, from close to the 2003 amounts. And then that graphic on the upper right shows you the hydrograph of the region, the Rio Grande region. So you can see, starting in the left side of that graph, from last year, we were pretty much in the bottom percentiles, and then until we got into the monsoon, the middle, we went well above average. But however, this is mainly the snow-fed problem, and although that we have a good monsoon, it didn't really help. It helped some, but it's what we really need is the winter storms to bring the snowpack to really make a dent in our long-term drought, and especially for surface water. So just kind of going into that's where we've been. Let's kind of look at where we're heading. So this is the probabilities for the ENSO El Nino Southern Oscillation. Starting over on the left side, the probabilities. We're already in a triple dip La Nina, and that's we're still going to be in that. There's still a 76% chance through the winter, and then transitioning to a neutral. You see that in the middle, the bar chart, where the blue bars are about the same height as the gray bars, and the probabilities, and then the probabilities are heading more into the neutral as we move into later spring. And then kind of what goes beyond that, we're not really sure. There's a possibility of looking at the transition. Either it's more likely a neutral, but there's a chance of an El Nino that could pop up. There's still a lot of discussion about that in terms of the total heat content of the Pacific. We're at really high levels, but it's going to take a lot to kind of transition that large amount of water, cooler than average, into warming. So there's still a lot of discussion about that. So maybe we'll talk about that in later webinars. So what does that translate into? So I just want to start off into kind of the outlooks. Shorter term, 6 to 10 over on the left is the probability for cooler. You've probably seen that come in. There's a lot, Arctic air mass, continental air mass coming in, bringing cold air. However, there's a ridge over on the Pacific, and then bringing over on the right is the precipitation probabilities, above average in the southern states and below in the middle of the country. Looking out at 8 to 14, that warmer than average pops up in most of the western part of the country, and then also for precip, likely below average to near normal for most of the Southwest. However, there's a trend for above average precip in the Pacific Northwest. So what we've been really looking at is the impacts of another La Nina, and so the indicators so far are showing that that's still to be the case, and so these are the outlooks for a typical La Nina pattern, above average in the southern tier states and below average temperatures in the northern tier, and then below average precipitation in the southern tier and above average and probabilities in the precipitation in the northern. So that's kind of the story. Further south you go, the higher probabilities, because of the La Nina storm tracks tend to be further north, bringing less moisture and to the further south you go. So that's kind of the pattern that goes here. And so so this is the last slide I'll have here, is kind of looking at the outlook for drought for basically through the end of the year essentially. So the drought is going to persist across much of the Southwest, and so that's kind of the story. There likely be. I was looking at some of the other models, the North American ensemble, and there was some other like the Euro model was showing a little different, but overall it looks like going to be below average for the southern parts of the Southwest, and maybe near normal precip for as you go up in latitude into the mountains. But wait and see. But it looks like likely above average temperatures. So that's going to be a major factor in looking at through our outlook. So that's not a good sign for snowpack. However, we're starting to see some snow, the snow water equivalent, pop up in our tracking. So I will, since we want to talk about the next topic, we're going to finish up, and then I'll give it back to you.
Thank you, Dave. That was great, really good information. We're going to hold questions to the end, till after Sagai's talk too. If any of you in the audience would like to ask a question for Dave, go ahead and type that into the questions box, and we'll get to that at the end. Sagai, I'm going to give you permissions to share your screen. And once you get that, you can just go for it. We're seeing your screen now, but it looks like a web browser with the GoToWebinar join information.
How about now?
We're seeing your presentation now.
Okay, let me use. Is it a presentation mode, or shall I swap it?
You want to swap it. There you go. That looks great.
Yeah. Okay. Thank you so much. Well, hello everyone. Developing a forest drought response index for what we call it ForDRI is one of the tasks on our USDA-funded project. The NDMC director, Mark Svoboda, is leading from UNL side. I'm one of the co-investigators and leading this specific task. What I'm gonna do today is briefly introduce you what ForDRI is, including its inputs, methods, and products or maps, and report the current and planned activities to evaluate the model and make this tool operational in the future. First, I'd like to acknowledge my team that are working on this specific task of the project. In addition to UNL experts here, as you may notice, Dave Hollinger, Northeast Climate Hub, is one of the collaborators on this research. We need more people, experts, if possible, from all regions of the CONUS who are interested in forest drought monitoring and assessment research. To give you a brief background, as you may know, monitoring drought impacts in forest ecosystem is a complex process because forest ecosystems are composed of different species with heterogeneous structural compositions. So we are making an effort to integrate several drought indicators that would help in monitoring the impact of drought on forests. So the project's main objective for this task is to develop Forest Drought Response Index, called ForDRI, that could help in identifying and monitoring drought impacts on forests. So ForDRI is expected to detect areas prone to tree stress that could help in taking appropriate mitigation measures. ForDRI is expected to help users such as US Drought Monitor, map authors, or drought experts and forest managers in characterizing drought across forested areas of the United States. We are using several approaches, including machine learning and big data analytics, to integrate climate, hydrologic, biophysical, and vegetation conditions indices or indicators to build a ForDRI tool using all these variables. The tool is specifically designed to be applicable to forest ecosystems in the US. This is the current ForDRI input variables, data sources, and spatial resolutions. All input data, original values of input variables are standardized as the first step. In addition, the input data sets are reformatted, reprojected, resampled, and masked or clipped for forested areas in the US. I will discuss this later in detail. This slide shows the conceptual method and the steps to develop the ForDRI. The concept of ForDRI is to combine important atmospheric or hydrological variables together, that's using a multi-indicator or convergence of evidence approach, so that we produce a better drought index for forests than any of each individual drought indices used alone. Currently, our ForDRI tool is composed of three major categories that include satellite, climate, and biophysical parameters. So the first step is input data collection and processing. All input data are also standardized to be consistent while integration of the data sets. The next step is combining these variables inputs based on weights. That's their potential contribution to the drought event. On integrating the inputs, there are several approaches or methods that we are implementing in research mode so that we determine the contribution or the weight of each input variables objectively. For example, we are currently using PCA-based method to determine each input's weights. We are also investigating other machine learning tools for future improvement of the models. Finally, the ForDRI is computed and standardized, so we calculate the final ForDRI values to produce ForDRI maps at weekly time step. We have already produced historical archives of ForDRI maps, but we plan to produce near real-time products to make it operational. After producing the ForDRI maps, one of the very important and challenging tasks is evaluation of the modeled product. We use different statistical techniques to compare with other drought products for evaluation. I'll show you some of the examples later. Well, the last step that's yet to be done in the coming months is the operational web delivery of the ForDRI maps or products. These selected 4 maps show examples of ForDRI maps or products. You can see the ForDRI maps for mid-August 2012, 13, 14, and 15. As I mentioned earlier, the ForDRI values are displayed on only the forested areas based on the US Forest Service forest cover map for the CONUS. To interpret the maps, the ForDRI values are classified into 8 categories, as you can see on the legend at the left side on this slide. The classes include extreme, severe, moderate, and pre-drought categories in the dry side to identify the stress on forests. I'll discuss this in a minute in the following slides. To evaluate the ForDRI, what we have done first is comparing the ForDRI with the US Drought Monitor for selected drought years. These side-by-side ForDRI and USDM maps are for mid-August in 2012 and 2013. Note that this comparison is a qualitative assessment that's mainly designed to do a sanity check. In addition, you can see that the gray color on the ForDRI maps that are non-forested lands, for example, agricultural, rangelands, water, and urban, which are not the focus of the ForDRI. In other words, ForDRI focus only on forests. Obviously, ForDRI and USDM are not expected to be the same. However, the long-term severe and extreme droughts are highly correlated with the forest drought stress. For example, if you see the 2012 ForDRI top left map, it shows severe to extreme drought over eastern Alabama and Georgia forests. That's also reflected on the USDM corresponding map. In contrast, the 2013 ForDRI map, bottom left, shows moderate to severe drought on forest stress over the western half of the US, while the eastern half US forests were not impacted by drought. So we have observed that the long-term high-intensity droughts have significant impact on forests that are also detected by the ForDRI. If you also see the 2014 and 2015 droughts, they were relatively extreme across the western and southern US. This occurrence of drought and their impact on the forest areas in the western US, for example, across the national forest in California, are depicted as you can see in these two ForDRI maps. To conduct a thorough evaluation of ForDRI, we attempted to consider independent ground observations that would help us for the quantitative assessment. As you know, tree ring widths are measured to build tree ring chronologies and to estimate radial growth rates. Tree ring increment generally has a positive relation to rainfall of a specific season. So we use this data set to evaluate our ForDRI models or products. I'll discuss the results in a minute. The second independent dataset for quantitative approach that we used is the Bowing ratio using Ameriflex sites observations. This is the ratio of energy flux from one state to another by sensible heat. For example, a negative value of Bowing ratio indicates that the latent heat flux, which is proportional to evapotranspiration, is greater than the sensible heat flux. And these observed datasets are also considered to evaluate the ForDRI values. This map is the forest cover type map that was produced by the US Forest Service. The ForDRI models are developed for only forest cover across the corners, as I mentioned earlier. The added red circles and green triangles on the map show the tree ring and Ameriflex sites that we used for evaluation of ForDRI that I will discuss the details next. Here are the preliminary results that we have found. Generally, about 27 sites out of 66 showed higher correlation, greater than 0.7, with p-value less than 0.1, out of which 19 were with p-value less than 0.05, as you can see in this table in the growing season. This is really an encouraging result. However, there were 3 sites with significant negative correlation. We are investigating the potential reason behind such negative correlation. This heat map chart shows where and when there is a significant Pearson's correlation for the eastern and western United States tree ring sites. As you can see, the western US sites are more correlated with the ForDRI values. That's the green and yellow colors. Further studies are needed to investigate the potential reason why some of the, the tree sites that are not correlated, or those sites with the blue and blue-black colors in the chart. In addition, we will also consider investigating the species difference that could have an impact as well. Having said that, these heat map charts show encouraging results that we can use as one of the convergence of evidence for our evaluation of ForDRI. To summarize my presentation, we have developed ForDRI models and maps for the continental United States. That's both Eastern and Western US. You may see the journal article published for Eastern US a couple of years ago at the top right. We'll pursue conducting more specific case studies that includes focusing on forest types, species, groups. In addition, we will collect feedback from forest experts and managers. For those of you interested, please let me know. I'll contact you for future collaboration. We continue to expand evaluation of ForDRI with ground observations, including the tree and Boeing ratio, to improve the models. We plan to publish a journal article on the results of continental United States with any one of you that are interested to be involved. We will also continue exploring the capabilities of ForDRI maps to be operational tool. Finally, I would like to mention that we have a plan to investigate how ForDRI can be used to manage forest drought impacts. For example, forest fire or wildfire, leveraging the ForDRI results. That's our future research. With that, I'll stop my presentation and let you ask questions if you have. Thank you for your attention.
Thank you, Sergey. I'm going to pass some time over to Curtis Riganti to moderate the questions.
Yeah, we'll go ahead and take any questions that people have, but sorry, Sergey, I had some pretty severe technical issues, so I just now joined the webinar a few minutes ago. I guess if this wasn't brought up in your presentation, is there anywhere that people can find current versions of ForDRI maps right now, or where can people go to find more information on that?
We do have the current version of the ForDRI map. We did for in August for this year, but because this presentation is so short and I didn't include everything, and I tried to cut it as short as possible. Yes, we do have. If you give me time, I can also show you quickly. Let me switch this. This is the ForDRI maps for current year, 12 August 2022. And so you can see the areas where the forest stress is. Would that answer the question?
Yeah, were you trying to share a screen, Sergey?
Oh, I didn't show the screen. Okay, let me show. How about now?
Yes.
Okay.
Is that on a website somewhere, or?
No, this is not operational. We are in the research mode. We are just evaluating it, and we are almost completing these preliminary evaluations. And we would like to do a little bit more, and so this would be available next year. However, if in the research mode, if anyone is interested to get in a specific time, and so that we are happy to communicate and then share some of the maps.
Great, sounds good. Thanks, Sergey. And then one question for Dave that came in. Why didn't the monsoon have a larger impact on reservoir storages this summer?
That's a great question. Well, you got to think of the amount of runoff that's produced. Even though we get a really good monsoon, it's the raw amount of acre feet that is produced from any one storm. Because in one storm, you may get localized, the monsoonal convective behavior. It could really make a big dump, and then one stream gauge, you can see it pop up to 10,000 cubic feet per second, but then it goes down, and that goes eventually into the basin for storage. But there's a lot of hit and miss that goes on, even over a 3 to 4 month period. It doesn't seem like it, but it's a small amount compared to the overall snowpack in the mountains for the entire winter. So it does help. You can get some good pulses throughout our system that goes, the water rises and goes into the river and and storage into the reservoirs, but it's still a smaller amount than the snow. And we really, in order to fill up our reservoirs, I have talked to several folks, and we need, several well above normal snowpack, that sort of, during El Niños, we need several of those to even bring their, especially like Elephant Butte and Lake Mead, more than one, like maybe a really wet period in order to bring those up. Hope that helps.
Yep, that makes sense. Thanks.
Great. Thanks to Dave Dubois, to Tsugai Tedessa, and also to Curtis Regante, who, despite some tech challenges, moderated some questions like a champ and jumped on in the end. So thanks to all of you for joining us today. We will not have one of these briefings in December because of the holidays. We just couldn't get our schedules to work out. We're planning to join again one of these half-hour Southwest Drought briefings again in January. The date is still to be determined because we're still trying to work out with the presenters of which dates work the best for them, but keep an eye on your emails and we'll send that out to you as soon as we get that organized, probably sometime in December. And for now, that concludes today's webinar. Another thanks to all of you for joining us, and I hope you have a happy Thanksgiving.